Sketch reciprocal function. Now we'll sketch reciprocal of a quadratic function here, whose equation is given to us as f of x equals to x times x minus 4. Now before sketching the reciprocal function, it would be a good idea to sketch the function itself. So to sketch this function, f of x equals to x times x minus 4, we can start with the x-intercepts. So there are two x-intercepts. One is at 0, the other one is at 4. So let's say these are the two intercepts. One is at 0, the other one is at 1, 2, 3, 4. Right. Two x-intercepts. Now this function opens upward since x is positive, leading coefficient, and it has a minimum at the midway, which is at x equals to 2. So let's find the value of the function at 2. The value is 2 times 2 minus 4, and 2 minus 4 is minus 2, so we get minus 2 times 2 as minus 4. So at 2 we have a value which is 1, 2, 3, 4. So this is minus 4 for us. Let me write down minus 4 here, and that is at 2. Okay. Another thing which we note here is the leading coefficient is 1, and therefore the function will have steps of 1, 3, 5, 7. That means from the vertex, if I move outwards 1 unit, then I should move 1 step, so I get 1. Then another time 3 steps, 1, 2, 3, that's perfect. And then 5 steps, 1, 2, 3, 4, and 5. Well, that's how it is. And from the symmetry, I get this points on the other side also. So it is 5 minus right there, right? So these points are the points on our function f of x. So let me join these points with the help of a light color. Since this is not really the function which we had to draw, right? The function which we are interested in is the reciprocal function. But in any case, it is very important to draw this function before we get into reciprocal function, right? So let me just connect them. There we go. So that's the parabola, and this is what we are treating as f of x equals to x minus 2, right? So let me write f of x here in this orange color. Now let's get to the reciprocal of this function. Reciprocal of this function indeed will be 1 over f of x, so let me call that as g of x equals to 1 over f of x, correct? That is what we mean by reciprocal, and that should be equals to 1 over x times x minus 4. So that is the reciprocal function. Now let's start with the vertical asymptotes. Now vertical asymptotes will be at zeros of f of x. That means these are my vertical asymptotes. They are not in the domain of the function, and at vertical asymptotes, let me draw the vertical lines, dotted vertical lines, indicating that these are the vertical asymptotes. So whenever you have x-intercepts for the function, the reciprocal will have vertical asymptotes at those points. You can see denominator is 0 at x equals to 0 and x equals to 4, and that gives us two vertical asymptotes. So one is at x equals to 0, the other one is at x equals to 4, right? So that also gives us restrictions on the domain, right? So let me write down here some important things which we observe, and that is domain. For our function now is that x belongs to real numbers where x is not equal to 0 and 4. Okay. Behavior near vertical asymptotes. Okay. So, if we are approaching vertical asymptotes, we know we are approaching infinity. Now, whether it is positive infinity or negative infinity, that is to be decided. So that is what we call behavior near vertical asymptote. Let's start with the one on the left, which is at 0. So if I am approaching the vertical asymptote at 0 from left side, which I could write as x approaching 0 from minus, that means from the left side, what happens to y value? This is what is called behavior near asymptote. So at this instant, y approaches what value? As we see that the graph of the function is positive, the reciprocal will be positive, correct? So y also approaches infinity, but it is positive infinity. So let me write y approaches positive infinity, right? So that means positive infinity. Okay. So we'll draw an arrow marking that if near approaching 0, the function approaches positive infinity. How about approaching 0 from the positive side? That means when x is approaching 0 from the positive side, what happens to y? The function is negative f of x, and therefore it should approach negative infinity, right? So that is how it is going to be. So it is going to be negative infinity. So that is the behavior as far as the x point is concerned, right? Now let's consider the behavior near the second asymptote, which is at 2, right? So what happens there? As x approaches 4 from the negative side, y should approach what? If we go from negative side, the function is negative, and therefore y is approaching negative infinity, right? So that is how it is. But if you are approaching 4 from the positive side, the function is positive and it is approaching positive infinity. So x, when approaching 4 from positive side, y approaches positive infinity. So that is the behavior near the two asymptotes, right? Which is marked in black, in red ink here. Okay, now let's look into the horizontal asymptote. Horizontal asymptote is when the function is approaching infinity, plus or minus, right? Let's consider what happens when x approaches negative infinity. If x approaches negative infinity, y is positive. So y approaches 0, right? But from the positive side. When x approaches positive infinity, that is this side, the function is positive, and therefore y approaches 0 from the positive side. So we see that the function approaches 0 from the positive side. So that becomes the behavior near the horizontal asymptotes, or end behavior, right? So this is what is end behavior. And what we find is, since the function is approaching 0, we have a horizontal asymptote. And the equation of horizontal asymptote is y equals to 0, right? That is the equation of horizontal asymptote. Okay, and we discussed the end behavior. How about the maximum? Well, the function has absolute minimum at -2. At 2, the value is -4. So the reciprocal will have a maximum, right? Here, so we have a local maximum. And it will be at 2 only, so it is at 2, and the value will be reciprocal of -4, that means -1/4. So -1/4 we can mark somewhere here, -1/4. So that gives us the local maximum for our function. Now we got good enough points to draw, but there are a few other important points which we can look into. We call those points as invariant points. Let me write invariant. Invariant points are points where y value equals to ±1. If y is ±1, reciprocal will be same, right? So that means they are common to both the graphs. Let's mark those points in ink. So these are the points on the graph where the function is -1. Do you see that? So the reciprocal will be -1. And these points here are +1. Reciprocal will be +1. It's kind of difficult to algebraically find it at the moment. Well, not difficult, but still. But on the graph, we can always mark them very easily. So it's a good idea to mark them on the graph. So now we have a couple of points here. Behavior near the asymptotes. We know the asymptotes also. even the local maximum, it's a good idea to sketch the function. Okay. To sketch the function, let's start with the local maximum and symmetrically bring it down as shown here like this. So we are approaching one of the asymptotes towards negative infinity. The center part is kind of like flat here on the top and dropping down. And on the sides, we'll be on the top quadrants, 2 and 1. Invariant point, let's start with invariant point, approach minus infinity on as the function approaches 0 and towards the asymptote on the positive side. On the right, well, so that completes our function. I hope you get fairly good idea about how to sketch reciprocal of a function given a quadratic function. So like we can go back and see what we did. So first step is of course to sketch the parabola itself, the quadratic function. Important things which we should mark here are the x-intercepts and the minimum value in this case. They help us to make the graph for reciprocal function. X-intercepts become the vertical asymptotes. And then you will notice that the graph is kind of 1 over x type on either side in quadrant 2 and 1 and upside down in the center with local maximum at x equals to 2. Now as an exercise, what you can also do is you can write range of this function. Let's add that parameter, that is range of the function, right? So let me write range as words. Let me push this paper a bit in front. So range is, as you can see, y belongs to real numbers, and the top half y is greater than 0. Y can never be 0 as we have a horizontal asymptote, and in the lower half y is less than its local maximum value, which is minus 1 over 4. So we can say y is less than and also is equal to, because that's the value it is equal to, right? Minus 1 over 4. So that becomes the range of this function. And with that, we can complete sketching reciprocal of a quadratic function. I hope you have clear concept of how to do it and what are the good values to show on the graph. So always remember, when you're doing reciprocal of a function, critical things to mention are vertical asymptotes, behavior near the vertical asymptotes, horizontal asymptotes, end behavior, which is behavior near the horizontal asymptotes, local maximum, minimum if possible, domain and range, and then invariant points, right? These are the points which you can always mark on the graph where y is equals to plus or minus 1, since reciprocal of 1 or minus 1 is the same number. I hope you enjoyed this video. Thank you and all the best.